Hello to everyone. Bismillahirrahmanirrahim. DCI Internet. Why are we here? We're here to discuss the journey of layer 2 VPNs. Back in 2000, the pseudowire was introduced, and soon after, the VPLS was born. At that time, we were able to give data plane learning solution for point to multi-point connectivity. Now we fast forward. Data centers are exploding. The shortcoming of data plane learning solution are beginning to show up. Now the question is, can we handle the Ethernet connectivity in a more advanced way? The answer is yes, and the answer is EoIP. My name is Moeez Aftab, and I'm an electrical engineer having some certifications of MTCRE, MTCNA, and CCNA in RNS, and CCIE in data center. For any follow-up question, you can reach me through my Facebook page, which is fb.com/straybits1byte, or you can reach me through my contact number as well. I was first introduced with MikroTik during my first job in Starlight Telecommunication. Over there, my boss asked me, do you know about MikroTik? I said, what is it? So this was the first introduction to me to the MikroTik, and the journey begins. And in superior connection, MikroTik is also acting as a core device. Well, soon after joining Cybernet, they have changed the CPO equipment from an XYZ company to MikroTik. Alhamdulillah, I have led that project. In Cybernet, we are facing challenges regarding providing the layer 2 solution to the end customer. We have our own concerns. If we are giving the layer 2 solution to the end customer, and if their machine malfunctions, and it will send the hundreds of thousands of MACs into your network, and it will melt down your network. So we don't want that much amount of MAC addresses into our network. So I have introduced the EoIP solution of MikroTik. Now they are using it nationwidely to provide the layer 2 solution to the end customer. And I would say that this is the biggest achievement of MikroTik, because Cybernet is one of the best internet selling brands in Pakistan. Currently, I'm working in Allied Bank. Thanks to my bosses, Mr. Tahir Ikram and Mr. Moeez Aftab, for allowing me to be a part of this MUM, although there's no MikroTik over there because financial sectors have their own concerns, and we are working on it to onboard this product. I'm giving workshops on MikroTik in Corporate Systems Lahore. And a special thanks to my mother. Whatever I am, it's because of my mother. So our agenda is packed. We will start from the 15,000 feet to the ground level. Firstly, we will see what is DCIE and what are the need of it. We will see different protocols that is going to extend the layer 2 domains. And then we will have a technical overview of an EoIP. And then we will see the design. We are connecting the 2 data centers by using this EoIP protocol. And we will see some configuration steps as well. What is DCIE? Data availability is one of the important factors nowadays. If there's an outage of 1 second, there's a chaos in the world. So we are designing our data. So every enterprise network infrastructure have its DR side, so that if one side goes down, the other side will serve to the customer, and customer didn't feel any kind of outage in it. So if they have the DR side, so they also want to utilize its resources too. So today we are designing our data centers in such a way that it will act as a one single data center. It didn't feel that they are placed in a different geographical locations. Now to connect the 2 data centers that are placed on a different geographical region and on a layer 3 network, it's a very challenging way. We have to take care of a lot of things. And in the case of virtualization, many things became impossible for us. So what we are doing is that we are extending the layer 2 domain so that the data center didn't feel that it resides on a different geographical location. I hope you get my point. That's good. So every technology have its business benefits. If they don't, there's no existence of a technology. So what is DCI technology? The benefits of DCI technologies are disaster prevention, so that if one side goes down, the other side will serve to the customer, business continuance, high availability, workload mobility. You can move your virtual machines from one end to another end with the help of, if you have designed your data center in such a way that it will extend your layer 2 domain. There are different protocols that that extends the layer 2 domain of your data center. So on IP infrastructure, the protocols that helps you to extend the layer 2 domain are L2TP, EoIP, and eVPN. And on MPLS infrastructure, the protocols that helps to extend the layer 2 domain are VPLS, eVPN, EVC, and NVGRE. And we are going to discuss the EoIP solution. Technical overview of EoIP. What EoIP is? Ethernet over IP tunneling is a MikroTik router's OS protocol that creates an Ethernet tunnel between two routers on top of an IP connection. So what I'm saying is that I have the two sides that are connected to each other over a layer 3 infrastructure. I have created an Ethernet tunnel over it so that my underlying network didn't feel that the other side of network resides on a different geographical location. My layer 2 domain is going to extend on the other side as well. And it happens on the layer 3 infrastructure. This is what EoIP does. So the EoIP uses the GRE protocol, and its protocol number is 47. There's an overhead of it. Everything have its pros and cons. So if we are extending the layer 2 domain, there's an overhead of 42 bytes as well. So we have to take care of things so that we might face a kind of fragmentation issue in that case as well. So we can talk to our upstream providers that you can increase your MTU so that you didn't feel this kind of overhead into your network. I have captured the frame, and this clearly shows that the underlying frame and the upper frame, and behind that, we have a GRE. So proposed design. Before going to proceed to this next slide, I would say that designing your data center is basically an art, is a creativity that resides inside you. And the only limitation in MikroTik is of your creativity. What it means that MikroTik gives you a granular approach to things so that you can design your data center in every possible way, the way you want. So take the idea, take the keynotes, take the important points, and craft your own. It will give you the confidence. So we are going for the model. I have the two data centers, site 1 and site 2. Each site is served by its own service provider. Site 1 is served by the service provider of 3. Its AS is of 3, and loopback is of 3.3.3. And site 2 is served by service provider of 4. It's AS of 4, and loopback of 4.4.4. Why I'm saying this? You should have to keep in mind these things, because we are going to look into it later. So every site is served by 3 links. 1 is of layer 2 links, and 2 is of internet links. We are going to manage our traffic in such a way, firstly, that traffic will go through the layer 2 link. If my layer 2 link goes down, my traffic is going to shift to one of the internet links. If that internet link goes down, my traffic is going to shift to another internet link. This is how I'm going to manage my traffic. These are the IP subnet that I have chosen. On site 1, I have the routed public IP pool, which is 111.1.1. And on the site 2, I have the routed public IP, which is 222.2.2. I have the connectivity subnets, which is on private subnets. Make sure everything is connected. So synchronize with this. And on a layer 2 link, I have also assigned an IP address to them as well. And an Ether 4 is of LAN. So what currently the service providers are adopting the way that they give you services on a fiber connectivity. That is their primary link. And with the nominal addition of cost, they will give you an RF link as well. So that if your fiber link goes down, if there's a fiber disconnectivity, the traffic is going to shift to the RF link. You might face a kind of latency issue, but with the help of this, you can avoid the complete outage. So in the 2 internet links, one is of fiber link, and other one is of an RF link. Fiber link is acting as a primary link, and RF link is acting as a backup link in the case of internet scenario. And on both of these links, my routed public IP is reachable. And I have a third one link, which is of layer 2 link, which is also given on me on fiber. We're configuring in such a way that the both routed pools are reachable to each other on both the data centers over both links, primary and backup link. On primary link, we are going to configure a BGP and a static route, while on secondary link, we will add only a static route with a higher administrative distance. After that, when both routed public IPs are reachable to each other, then we are going to create an EoIP tunnel over it. We will create another EoIP tunnel as well on the layer 2 circuit as well. And after that, we are going to manage on which tunnel our traffic will move on. I hope you are synchronized until now. And you have to keep these points into your mind, because in the next slides, we are going to discuss all of these things. So firstly, you have to name the interface and assign the IP addresses. Then you are going to configure a BGP. As I told you before, on a primary link, we are going to configure a BGP. And for the sake of BGP, there are 3 important things you have to consider. Firstly, you have to define your own AS, which you are going to configure in the instance tab. Secondly, you have to configure the remote address, the IP address of from the connectivity subnet of service provider. Thirdly, you have to configure the remote AS, the AS of your service provider. As you can see clearly in this picture, I have configured the 3 things. Now my BGP's neighborship is established after configuring these 3 things. And in other important thing, what is the TTL value in the case of eBGP and iBGP? Well, in the case of eBGP, you are establishing a neighborship which is directly connected to you. So in that case, the TTL value is 1. But what if your neighbor is 1 hop away and you want to create an eBGP relationship in that case? What you will do? You will increase the TTL value in that case. Well, in the case of iBGP, the TTL value is 255. It means that the neighborship is going to be established where up to the multiple hops away, these hop is of layer 3 hops. It's not of layer 2. Got it? So we are configuring basically the internet link. We have established a BGP. And for the sake of internet links, we need a default route. We need a default route for the sake of internet links, for the sake of internet. So in the case of BGP, there are 2 common practices that we are using. Firstly, either your service provider will inject the default route into your routing table through the BGP. And secondly, they will advertise a loopback to you. And what you will do is, you will add the default route towards that loopback. In our case, in my case, my service provider is advertising its loopback, which I have defined you before, which service provider 3 is having a loopback of 3.3.3, and service provider 4 is having a loopback of 4.4. So we will add the default route towards that loopback. For the advertisement, you should be careful about the subnet mask as well. Now we have, as I told you before, for the configuration of internet links, firstly, we have to configure a BGP and a static route. And secondly, we have to configure only a static route within higher administrative distance. You can see in this picture, I have added the static route, default static route towards that loopback that is learned from my service provider within administrative distance of 1. While on the backup, I added the default route within higher administrative distance, so that if my primary link goes down, my loopback is not reachable to us. And what happens is that it will take the route within higher administrative distance, as you can see clearly in this picture. But there's one thing more came into it. And what is that? It's the recursive route. What is recursive? Recursive is that we are adding the gateway that is not directly connected to us. That is the loopback. And that loopback is learned by eBGP. And it is far hop away. It's not directly connected to me. So that is basically a recursive routing. So every route that is placed in your routing table have its scope value. You have to take care of this thing very importantly. This is the very important thing. So in our case, we are having the gateway of 3.3.3, which is the loopback of my service provider. So in that case, its scope value is of 40. So we have to change the value of target scope value. Otherwise, this route won't get active. We are adding the default route towards that loopback with distance of 1 and target scope value of 40, because that loopback is learned from an eBGP, and every prefix that is going to learn from eBGP having a scope value of 40. So we have to change the target scope value in our case. So until now, we have managed the failovers. So until now, we have managed the failover that our primary traffic will go through the PGP, and when my primary link goes down, my BGP neighborship goes down, my traffic will shift towards the backup link. This is how we are going to manage into the failover of internet lines. So both routed pools, both public pools are now reachable to us. Now we are going to create an EoIP tunnel over it. As you can see clearly in this picture, it's 111.1.1, it's my local address, and 222.2.2, it's a remote address over which I'm creating a tunnel. I will create another EoIP tunnel over my layer 2 link as well. Make sure the tunnel ID should remain the same on both sides. But there's another important thing over here, the local address. Why I'm mentioning the local address? It's really another important thing. Well, when traffic leaves from your router, what it happens is that it will definitely take the source address. And in our case, we have a routed pool. We have a routed public pool. So whenever traffic leaves from the router, it will take the source address from where it is of that interface from which it is leaving. So in our case, the interface from which it is leaving is having a private IP address. So what happens is that when traffic goes for the 222.2.2, the reply won't come back. So we particularly have to mention the local address, my own public address, so that when traffic goes to the 222.2.2 and it will return back for 111.1, it should be reachable to each other. That is why we have to particularly mention the 111.1.1. So until now, we have created the two tunnels, the two EoIP tunnels. It's similar like that. We have a switch on both sides, and we connected the two switch with the two wire links. We have connected the two Ethernet cables directly connected to the switch. And what happens when the two switches are directly connected with the Ethernet cable? It will create a loop. And to avoid that loop, what you will gonna do? You will go layer 2 loop avoidance protocol, which is an STP. So we will use that to manage on which tunnel our traffic will move on. So we create a bridge interface. This is the bridge, and we call both of these tunnels and the LAN interface as well. Over there, you can see that with the help of an it's an RSTP is running. So with the help of an RST, I have decided that this is my alternate port, and this is my root port. So when this link goes down, EoIP tunnel 2 goes down, the traffic is going to shift on EoIP tunnel 1. This is how I'm going to manage on which tunnel my traffic will move forwarded. Right? So we have created the EoIP tunnel, we have connected the two data centers. It's all done. What's next? Is it necessary to run an STP? Yes, it is. So we have dressed up our network. We have connected our two data centers. Now we just have a makeup of some things. We have to take care of a little bit of things. So what is it? If we are running an RSTP on a MikroTik, so definitely they are making a BPDUs. And that BPDUs is for the decision for the MikroTik. It's not for your network. So you particularly have to care of this thing. I have captured the frames from the MikroTik towards the network, and it will shows me that it is sending BPDUs continuously to my network. So particularly what you have to do is you should make an edge port as yes of your LAN interface. This is your LAN interface. So these are the basically tips and tricks that you have to take care of these things. Second solution is that you bond your EoIP tunnels and then call them into the bridge interface. This will increase the throughput value and a load balance as well. This is its configuration of bonding. That's it. Until now, I have I have seen things from as a client perspective. Until now, I have seen things as a client perspective. I'm designing my own model. What if if I am a service provider, I want to give the services to the customer, I want to extend their layer 2 domain. I have to take care of there's a little more extra in it. What you will do is, for the sake of, from a service provider perspective, you are going to extend a particular VLAN. So for that case, what you will do in your MikroTik is you create a sub-interface of that particular VLAN and call that in EoIP tunnel. But from service provider perspective, we are creating multiple EoIP tunnels over a different IP subnet. Why I'm doing this? This is a question. Why I'm doing this, why I'm creating a multiple EoIP tunnels and a different IP subnet to apply the queue policy. Definitely we have to limit our traffic, to limit our layer 2 traffic. How you are going to limit our layer 2 traffic? Either you apply the policy, the QS, the rate limit at layer 2 level, at switch level, or you can apply the rate limit policy in a MikroTik. So with the help of layer 3, you are limitizing the layer 2 bandwidth. And for that purpose, we have to create, for multiple IP subnets, firstly we create a GRE tunnel between the two sides, and then we will create, we'll having a different subnets on both sides and run, and both of these subnets need to reachable for both of these subnets. Either we run a routing protocol or we use a static route to make the private subnets reachable to each other. And on those private subnets, we are creating a tunnel. Firstly, I have created a GRE tunnel. And then I have assigned a private address to a bridge interface and a private address to my GRE interface. And after that, I'm going to create a bridge and I'll assign a private IP address and run the OSPF on it. After that, I'm going to create the EoIP tunnels over these private subnets. Rest remains the same. We have to create a bridge interface and call that these things. And this is how I have limitized my layer 2 traffic. By playing with the layer 3, I'm limitizing my layer 2 traffic. By static route, we are also reachable to. This is a home assignment to you guys. If a client demands that I need a high availability along load balancing, what we should do? To answer this question, you can reach me through my Facebook page or through my contact number. Any question? Any question? Yes, please. Please stand on the mic. Please stand on.
In the part of where we are talking about the RTP under the bridge section,
yes,
you said you are selecting one EoIP to be the alternate route and the designated ports. Were you doing this under using the STP or RSTP? And was it under the bridge interface?
I'm running an RSTP over it, but it doesn't matter. You can run an MSTP on it as well. It's up to you. Okay.
Secondly, I've not seen the part whereby you said we want to encrypt the EoP through.
No, I'm not encrypting it yet. I'm not encrypting yet. I'm just interconnecting it yet.
Okay. And in case you want to do the encryption,
it's a layer 3. It's a layer 3 encryption. You can do on a layer 3 security whatever you want to do.
What is now the recommended size of the MTU to be able to do? What is basically the recommended size of the MTU to be able to carry between one data center to the next one, and also to be able to pass VLANs in the same EoIP?
You will calculate it. It's a 42 byte of EoIP, and rest is up to you, whatever you are going to add in it.
Any best practice?
In 42 bytes, we are adding the Ethernet header as well. There's no need of addition of VLAN. But above, if you are having an IPsec, the header of IPsec you're going to add in it. So it's calculate you can.
Any best practice on the MTU size?
No, I don't have a recommendation of anything.
Okay, thank you.
Any other question? It's layer 2 extension technology, guys. Yes.
My question is regarding the BGP.
Yes.
You are changing the target scope.
Yes.
Why are you doing that from the default?
Yes. The thing is that the gateway that I'm using it is learned from BGP. That prefix is learned from BGP. Just a moment. It's too far away. Yes. You can see that the gateway, the 3.3 which I am adding, this prefix is learned from an eBGP. This prefix is learned from eBGP. This is the loopback of my service provider. Remember, I have told you before that I am having a service provider 3, which is having a loopback of 3.3.3, and service provider 4 is having a loopback of 4.4.4. In the case when BGP neighborship established, this loopback will be advertised to the customer. And what we will do is that we will add the default route towards that loopback. And that loopback is learned by eBGP. So I told you that every prefix in our routing table having a scope value. Well, the prefix that is learned from an eBGP relationship is having a scope value of 40 and above. So in that case, we are changing the target scope value because we are directing our traffic towards that loopback. And that loopback is having a value of 40.
I think that is not the appropriate use for scoping.
Appropriate use, sorry?
You see, there's target scope and there's scope.
Yes.
Who gives you the scope? Do you go, because there you're inserting scope, is it the ISP who's giving the scope?
No. It's the default. It's the default. That you can, if you go for on a MikroTik website, and you can see that there's a scope values of every route. I can show you. I have an internet connectivity. Just to give you, it's in IP route. It's not what you decide. See?
Yeah. Very clear. Those are the defaults, but
yes,
you are changing them.
No, I'm not changing them. I'm not changing them. I'm adding the route. I'm adding the route in which I am defining that my target, the traffic which I am addressing to is having a value of 40.
Okay.
In this thing, I am defining that this prefix having a value of 40. This is what I am doing. But if you are talking about I am changing by myself, then this should be in scope. By changing the scope value, I am changing basically the value of the route in the routing table. I'm not changing the scope value, I'm changing the target scope value.
Okay, that's clear. I see the clear definition for it.
Okay, it's all right.
The other thing is,
yes,
as Labat is asking, what is the MTU in this network? You see this network that you've built?
Yes.
The MTU is around 1458, yes?
Yeah, there's a 42 bytes of an override of an EoIP.
So why are you using how did you pick the tunneling that you're using? Why not use VPLS or use other technologies in a MikroTik?
Yes, we can use that, but it is every technology have its requirement. For the sake of VPLS, we have an underlying infrastructure of an MPLS.
Yes.
So,
which is routed. So why using EoIP tunnels and GREs?
Dear, if you are connecting from Kenya to Pakistan,
Yes.
what you will do? You will buy an MPLS infrastructure from end to end.
Yes, you can.
It's a very expensive one.
No. You route it and then load VPLS on top. I've done it.
It's a very expensive MPLS circuit. It's a very expensive one. While internet is a very cheapest.
No. I'm saying.
Yes.
You have MPLS.
Yes.
You can route your network and
Yes.
then apply VPLS on top. Because you see, the problem with this design is you're accumulating MTUs.
Dear, this is the thing I have told you that for the sake of MPLS, we have to build an MPLS infrastructure from one end to end. On that, you are going to run the VPLS. In the case of EoIP, you do not have the requirement of anything. You just have the requirement that you have an IP reachability from one end to another end. If you are living in Kenya and you want to extend your layer 2 domain from Kenya to Pakistan, what you will do? You will buy the MPLS infrastructure from end to end. It's a very costly one. On EoIP tunnel, you can extend the layer 2 domain. All you need is that internet connectivity, which is on both sides, which is a cheaper one. Got it?
You are saying we can't route for VPLS?
We can, but it's a very costly solution.
So why not use it to reduce the MTU?
Why not?
Use it to reduce MTU. Because you see, when you start talking about ISPs, the problem is MTU.
It's all about the cost. VPLS is costly thing, costly solution. EoIP is not a costly solution.
Okay.
Anything else? I hope you get an answer of it. I hope you are not just agreeing to disagree. So, any other questions? Thank you then. Allah Hafiz.